All right, so as we're getting started, do y'all have any questions from 1, 2, or 3 that we did last time?
Well, the quiz, like one of the questions on the quiz was about the lighting, like what light did the hard drive display? What one was this NAT? It was like green, you know.
Oh, that's the on the motherboard.
Yeah, the
Oh, okay.
Front panel.
Talk about that.
There is a question was just asked about the color scheme. There, and I'm glad you mentioned that because I forgot, and the slides don't. It's called the PC98 standard color scheme. Look it up on Wikipedia. The ones that you really need to know are the ones on the back. And like they might ask about the in the old days with PS2, you had purple and green. And you had to know which one was the mouse and which one was the keyboard because they weren't labeled on the computer. Now USB has kind of done away with almost everything like that because it doesn't really matter what USB. Like I don't know if I plug the keyboard and mouse into this laptop the same. Sometimes I plug them in on the other side. Windows doesn't care anymore, you know, and neither does the computer. But make sure you know the PC98A parts that are for the mouse. There actually is a standard color scheme. Up crystal clear till I started Camtasia. Somebody said at home, huh? I may have to check and see if I can't find a better way to record then. That is kind of odd, but I'm not surprised. I looked at the video and everything was clear in the video, so maybe Camtasia is stealing the audio on this thing in some which of a way. PC98A color has a color scheme for everything. And some manufacturers still use it on the back so you'll know, but almost everything's labeled now too. But they are the ones where, like the different colors for 5 surround sound, all of those different little colors, that comes from there. I don't expect you to get a question on the actual test about that, but you might. When I took it, it was a big thing to make sure you did know the difference in the mouse and the keyboard, because they were still manufacturing computers in with PS2 ports on it. Now they're in a single computer in this room with a PS2 port on it, so it's not as big a deal.
I saw one like this past month that was new that had a half green, half purple PS2 port.
One connection now.
One for both, so in case you've got an old device that's like your favorite keyboard or mouse or something, you could plug it in. Huh, I've never seen one of those. That's
whenever I saw it, I was like, huh, that's odd.
That's exactly what it is, though, if it's half purple and half green. So, okay. Let's see here. Slideshow from beginning. Alright, so we're going to talk about BIOS, CMOS, and firmware. And what these do for us. We want to make sure that you understand the BIOS, the CMOS, and the firmware. We're going to talk about the motherboard's firmware, which is the BIOS, and the relationship between the CMOS and the BIOS, and where those names come from. You'll notice that they're capitals, so they're acronyms. We'll talk about how to configure the BIOS, how to access the BIOS to modify settings for RAM, processors, and video, things like that. We're going to talk about what's called the post. Post is the power on self-test, and that's what your computer does every time you turn it on and you see it counting up the memory, or a graphic screen comes up, and what errors are reported there. And we're going to talk about the process of updating the BIOS, which normally that's called flashing your BIOS, and why you may need to do that sometimes. So BIOS stands for Basic Input-Output System. BIOS is the firmware that identifies connected system devices, such as the CPU, the RAM, the keyboard, the mouse, CD-ROM, and usually some sort of basic display.
Really? Remember the BIOS, BIO, for like biology? It's the lifeblood of the computer.
That's actually a good way to remember it. Somebody in class just mentioned, think of BIOS as BIO, like biology or the life of a computer, and that's exactly what it is. The BIOS is what actually gets the computer up just enough to get started so that it can load like an operating system. The BIOS also includes the POST, or the power on self-test, that actually runs everything. The BIOS is found in firmware. And firmware is software that comes embedded in its own memory chip. There are two types of memory that are used for BIOS. There's EEPROM and EEPROM. EEPROM is the old type. Y'all are not probably ever going to see a computer that actually uses EEPROM anymore. EEPROM is where the name flashing the BIOS actually came from, though. Because with the old EEPROM chips, once they were programmed to erase them, you had to take them out of the computer and put them in, for what all practical purposes looked like a little bitty tiny mini tanning bed that had ultraviolet lights in it. And those chips, I wish I had one to show y'all. I used to have one, but I don't know what happened to it. They actually had glass in the top of the middle, and when you put it in that ultraviolet light, it would erase what was on the chip. Thus, you were literally flashing the chip. It took about 35-40 minutes for it to erase them.
Once you did that, you covered that up.
Yeah, you can make it right. Yeah, once you could basically write protect them by putting some black tape over it. So that's where the term flashing comes from. But now everything is EEPROM, and EEPROM can be done by the computer.
Before that, there were just proms, and once you burned them, you couldn't redo them.
Right. Yeah, that's true. Before that, there was program once, and once you program those, you couldn't do anything with them. Your EEPROMs are what all of your current stuff is going to be, though. And it is programmable by the computer. It's electronically erasable. So, like nowadays, when you flash the BIOS, you'll either boot up off of a CD or a disk to do it, or some of the newer motherboards, you'll even do it inside of Windows. But it has a program that will erase it, and then you rewrite it, instead of having to take it out and put it in one of these devices and all of that. So here they're showing the locations. It can be in different places on motherboards, but it's usually near the battery. And there are different types of sockets that these can be in. One type was called a dip type socket, and that was kind of a larger chip that slid down into it. The PLCC type socket is something that you see a little more, and it kind of looked like a mini CPU. You would slide the chip down into it, and it didn't actually have pins on it. It had little round ends on the side. And that's number 2 in this graphic. And the way you would actually take that chip out is use one of your little bitty screwdrivers, like a jeweler screwdriver, and slide it down into that corner to pop it out. 3 is surface mounted. Those are not real common for BIOS. Most BIOS is still removable from the motherboard, because if you truly have a problem with the BIOS chip, your computer is pretty much unusable. And then 4, they're showing, you know, the location of the batteries on these. So CMOS stands for complementary metal oxide semiconductor. CMOS is a type of memory. It's a type of RAM, which means that the information on it can be lost if there's no power source. 2 terms you're going to hear a lot about: volatile and non-volatile. Things that are stored in RAM are volatile. That means if the power is removed from it, the data is gone. Solid-state hard drives, even though you don't want to think that, they're volatile. They have batteries on them, and if that battery loses it and it quits storing, you know, keeping that data charged on that hard drive, they will lose their data. That's why solid state's great and fast, but they are not as reliable as a non-moving traditional old drive would be. So that battery keeps the settings in that BIOS. That's what the battery on your motherboard is for. CMOS stores the settings used by the BIOS. Like what hard drive is supposed to boot up first, or if you're going to allow people to boot up off of a CD-ROM drive. If you've put a BIOS password on your computer, that's going to be stored there. These options are passed on to the BIOS right after you turn the computer on. And those settings are changed by what's called the CMOS editor.
Power up, the information be transferred from the BIOS?
It would be transferred from the CMOS to the BIOS. The settings would be in the CMOS and they'd be transferred to the BIOS.
So the CMOS is what is reset whenever a battery dies.
Yes. The BIOS is permanent, but the settings are gone. That's why if you ever, like if you plug in a machine that hasn't been plugged in for a long time, and it may boot up and say, I've lost all the settings, that's why that battery has finally charged down or something like that.
The BIOS is in the CMOS.
On some it is, on some it's not. It does not have to be the same chip.
Maybe two chips, but still it's in a chip.
Right, it's two separate components though.
What's in the CMOS if it's not the BIOS?
The settings for the BIOS are in the CMOS. Only the settings. The BIOS is the program that boots the machine. The CMOS is the settings that are transferred over to the BIOS. Like how to, the time and how to boot the hard drive and...
CMOS is a certain type of chip. And the BIOS is stored in the CMOS.
No. Mm-mm.
CMOS is flash memory
Chip name.
that...
The chip's style, the way it's made, the CMOS, that's metal oxide.
Well, yes, but they're technically... You're right from where the name comes from, but they're two significantly different things. One is the program that boots the computer. One is the settings for the program that boots the computer. Like, I understand what you're saying, and yes, they probably are both CMOS chips, but what we call a CMOS as far as software-wise is the settings for the BIOS.
I would think the program would be not changeable, but the variables that you change, your variables or whatever your options, they would be programmable. You know what I'm saying? Because when you reset it, the format or the database stays fixed, and your variables you change, your options, you can change those. I think they're. I'll look at it. I think it's all in the same chip. Just one's permanent, the other ones are.
Right. I know on my motherboard they're not in the same chip. They might be in one that you've got.
I'm just thinking that CMOS is a term for a type of chip.
Right. It is a type of chip, but in this case it's also settings. So that's one of those things where it's two different names. So getting into access this, you have several different key presses that it could be based on who made your motherboard. On some you hit escape when you're booting up. On some it was Control-Alt question mark. I think on all of these Dell machines it's F2 or is it F12? It's one of those. So basically most different motherboards when they boot up, they're going to show you what key to press to get into the settings. And this is one of those areas too, like where I'm trying to be careful with what words I use, because in the real world I would just call it all, like your point is it right? I would call it all BIOS. I would say go into the BIOS and change a setting. But technically you're going into the CMOS to change a setting. In the real world, however, people do just usually say BIOS for all of this. I just want to make sure y'all know the distinguishment for the CompTIA test in case they asked you one that's specific on that. Because like they're going to want you to know that CMOS is non-volatile and the BIOS is volatile. They're going to wait and make sure that you know that part. Are y'all following me?
I don't know where are the two chips on the board here. I mean, you said there's different chips. Their picture, there's a battery and a chip. Where's the other chip?
On theirs, I don't know.
So you remember, you can create a database, and you create a data entry sheet. That data entry sheet, you created it. It's hardware or software, but the user can't change it. The user can change the fields. So I think it's the same thing where the structure is like firmware, and the options are like EEPROM data. I mean, I'm not sure if I looked at it.
Right, but that's normally on an EEPROM chip, and one's going to be on a different chip. Not always. I mean, you know,
I'm thinking they could be in the same chip.
they might be. I mean, check me out. I've been wrong before, but
Show for one chip. Do it on page, whatever that page is. Does BIOS location look better?
on theirs, they're showing a BIOS.
But it's also a that metal oxide works so good. No current goes through the gate. It's a charge, and that's why the static thing is a big deal, because any static can blow that gate and damage it.
All right. I mean, I'm not going to argue with you. You
I'm
might.
not either. I'm just saying. Well, see, I come from a hardware perspective.
Right, and I don't. I'm not a hardware person.
And I can find out for sure.
I tell you, actually, on my motherboard, there's 2 chips, and there's also 2 backup chips. And you're going to see that a lot in newer motherboards, because if you do screw that up, you're right, you can't do anything with your machine.
The CMOS, even if there's 2 CMOSs, one can have the permanent data, your table, if you will, or your form, and the other one can maybe where you put the options.
It's very possible. So, all right, there are different ways to get into the BIOS. Escape on some machines, delete on others, Control-Alt question mark. If you're in doubt and you can't figure it out, either get on the internet and look, or look in your manual. It's going to be in there how to get into the settings. Manufacturers tend to standardize. Like all of these Dells tend to be the same way. I'm pretty sure it's F2 in here, and then F12 is your boot menu.
And they usually say when you're booting up, hit F2.
Some do, but for security, in some cases, you disable that, because you don't want, you know, just a user. It's one more little step of trying to keep a user from getting into something. I mean, you should password it as well if you're concerned about that, but if you don't tell them that that's an option to press a key, they don't know to press it in a lot of cases.
A lot of newer machines actually go through that. I've noticed go through it so fast that you can't figure it out and press it in time.
Right. On my motherboard, the default is to actually have a graphical little picture that comes up, so you don't actually see any of the post messages unless there's an error. And you can go in and turn that off, but I think there are more and more that are doing that graphical BIOS now. So some of the more frequently used options in here are going to be things like the boot sequence. If you've got a computer with more than one hard drive in it and more than one operating system, you might need to tell it what drive you want to boot up first. This is also where you set the boot order. Like if you want the CD-ROM to be able to override booting from the hard drive, you change the order of that. You can set the CPU clock frequency here, which is where you would do what's called overclocking. And overclocking is that you're going to speed it up a little bit from what it's actually designed to do from its specifications. A lot of newer motherboards now, you can do all of this with software. On the older ones, you had to do it in the BIOS, and if it didn't work, you had to go back in there and do it again. There's usually a hardware monitor in there, and that is to look at the temperature in places inside of the computer, like the temperature of your CPU, and if all of your fans are running. And the purpose of that is because, like the CPU, for example, gets very hot very quickly. If that fan on the CPU stops, it will not take long before your computer will overheat and just melt itself. So they put safeguards in there. You can turn a setting on where if it detects that fan doesn't spin up, just power the thing off. Which is, you know, even though that's bad for an operating system, that's safer for the hardware than letting that thing run without a fan, without cooling. Usually this is where you will enable and disable the integrated peripherals. Most motherboards now come with onboard things like a little onboard video card and onboard sound and things like that. And if you have, like if you've got your own, if you're running a special sound card for some reason, like not many people need to do that anymore, but let's say you're really into music and you have a MIDI card. You're going to plug a keyboard into your MIDI card on there. You have to disable the onboard one before you put the card in. A lot of motherboards do have a basic built-in video card, but most people, especially home users and gamers, are going to get a much more powerful video card. So they'll turn that. You have to turn that onboard video off before you put your other video card in. All of these Dells have got onboard video, and since we don't have dual monitor in here, we're just using it. But in our lab over at Bipsy, I've got dual monitors. So what we had to do was go in and change the settings and turn the onboard video off on them all before we put the other video card in it. USB keyboard options there. You don't see that setting as much anymore. In the old days, you had to turn on if you were going to use a USB keyboard, that you wanted to use that over a PS2 keyboard. And that was one of the most aggravating things in the world, because if your keyboard died and someone gave you a USB keyboard, you couldn't go in and turn it on. And what does the computer say when there's an error? Press F1 to continue. How am I going to press F1 when I don't have a keyboard? So I'm glad they worked all of that out. If your computer has serial and parallel ports, again, lots of machines don't have those anymore because USB has replaced just almost everything. That'll be there. And the power management settings are there. How you want the machine to suspend. Settings on these Dell include how you want it to power back up if the power turns off. Like, do you want it to power itself up or stay in a state off? And that's because you might be using one of these as a small server. And if you, like our small server across the hall is just souped up one of these. We don't have the money for a UPS over here, so, I mean, it's not the best thing, but if the power goes off, it's going to go down. I set it to turn itself back on so that if that happens, I don't have to come up here and push the button. It'll just power itself back on when it gets power. So lots of BIOS now also have automatic configurations. And what I mean by that is they will figure out almost everything on the computer. Unless you're going to overclock it, for example, on most more modern motherboards, whatever chip you put in it, it detects the speed of. You don't have to go in and change those settings. There are usually 3 settings. There might be a BIOS default, a setup default, and a turbo. And turbo is the setting that would do some tiny overclocking. Here's an example of a BIOS screen. They all look basically the same. I mean, they're a little different based on what kind of computer it is. Here's some of the settings. This one's showing the amount of memory in the computer and what version the BIOS is. So here they're showing things that are considered integrated peripherals. On this one, some options are onboard video and audio, an onboard network card, an external SATA drive port. That's going to vary a little from motherboard to motherboard, just what you bought and what the functions on it are. My motherboard, for example, I didn't need it, but it was something that came on it. I wanted a good motherboard that I could run an AMD Black on, and it actually has 2 onboard network cards. So I went in here and disabled one of them because I have no need for 2 network cards in my computer. Alright, so in power management, we have something that's called ACPI, and it's Advanced Configuration Power Interface. And ACPI basically are states that your computer can be in. S0 is that no power management is running. Your CPU, memory, hard drive, everything is just going full speed ahead. S1 is power on standby. S1 means the CPU is off, but the memory is being refreshed. The hard drive is off at S1. S3 is suspend a RAM. This is basically like standby mode. The RAM is refreshed, but everything else is kind of turned off. And then there's S4. S4 is hibernate. And if any of you've got laptops, you may have seen S4. The default for Windows when the battery gets down to like 3 or 4% is to hibernate the machine. which means it writes the memory to the hard drive and then completely turns the thing off, because it feels like it's going to run it. You're going to run out of battery before you're able to do anything else. Then when you plug it back in, it'll read that back out and into memory, and the computer will be right wherever you left it.
Resident memory or the CMOS?
The resident memory, the RAM. Yeah, unless the battery, unless your CMOS battery dies, your CMOS should always be being refreshed.
You were talking about the other battery, the laptop.
Yeah, like your battery on your laptop, right? Your actual battery. I'll know on my test, I got questions on these different levels. You may or may not, so I would take a little bit of time and make sure you know them. Especially know, like S0 means nothing, no management is running. S3 is what most people, their laptops are set to when you just close it. Like if I leave class tonight and I don't turn mine off, I'm just going to shut the case. It's going to go to S3. But you can configure those settings in the BIOS on a laptop. You can say if you want to do a different one.
Actually, I know at least with Windows 7, you can configure most of that without going to the BIOS.
You can do it with the operating system.
Yeah.
That is becoming more and more common, and a question was just asked online: when would it be preferred to set power management options in the BIOS versus the OS? That's a good question, and there's really not an answer to that anymore. The lines between all of these are getting more and more blurred with these more and more advanced systems and BIOSes and such. Overclocking, for example, I overclock mine a lot, but I don't do it all the time. And with my particular motherboard, there's software you can run that'll overclock it on the fly for you. So if I'm going to play a game that needs a whole lot of memory or a whole lot of processing, I'll overclock it without ever rebooting it or going into the BIOS or CMOS or anything, and play my game, and then I'll turn overclocking off, and as soon as I do, I hear my fan start slowing back down. So you don't have to do a lot of that in the actual settings on the computer anymore. All right, so overclocking considerations. Should you overclock? That is a question that's completely up to you. They say here exactly these temporary overclocking in unusual circumstances like gaming. Prolonged overclocking means you need a bigger PSU, a bigger power supply, and a bigger fan and bigger cooling. Your final in here, remember, is going to be to build a computer. I'm going to give y'all a fictitious amount of money and let you go and put one together. So something you can consider, you're getting a good bit of money to do a machine, you may want to overclock it. And if you're going to do that, you might want to put more fans in it. I made sure that I got a case that's got fans in the front, back, and two on the side, 220 millimeter fans on the side. Because I want, if I'm going to overclock, I want as much air running through it as possible. Some people that do extreme overclocking now have moved to water-cooled CPUs. Instead of actually cooling it with just a heat sink and a fan, you run basically a little mini refrigerator through the thing. The thing to learn here that with overclocking, heat is the enemy. The colder you can get the machine, the more you can overclock it. If y'all just kind of want to see something that's interesting, do a YouTube search for extreme overclocking. There's a guy that did research and took a 3.2 gigahertz AMD processor and designed a fin that kind of sits on top of it and filled it with liquid nitrogen. And overclocked that sucker to 7 gigahertz and it ran fine. But of course he's boiling his nitrogen off as quick as he can pour on it, but it worked. It actually worked. So there's no limit if we can get rid of heat. Heat is the enemy of anything electronics. You know, the more you can get rid of it, the better.
The colder it is,
That's the whole system submerged in liquid nitrogen.
You probably could.
To lower the resistance of the wire.
I've not seen one that was in nitrogen. I saw a computer that someone had put in mineral oil. Under that same idea, mineral oil is not conductive, and they got a fish tank and filled the fish tank with mineral oil, and put their motherboard down in the fish tank, and then ran their wires up, and their hard drives are sitting on the side, and they put their aquarium bubbler down there to bubble it up to move it around, and it works. I never would have thought about putting a computer in mineral oil, but
I really want to do that now.
it's kind of neat when you look at it, because you think they're running that motherboard in water. What the heck are they doing?
Wow, that's cool.
Yeah, somebody at home just made a face about water cooling. I would like to have water cooling in my machine. I didn't have enough memory. I spent all my memory on RAM when I built mine. Yeah. What did I say, memory?
The mineral
Can
oil,
y'all tell I've had Benadryl today? I'm done.
the mineral oil cools really well too?
It pulls the heat away. Yeah, basically any liquid would.
As long as it doesn't get too hot.
I'm going to have to do that now.
So there are error codes that will come up. The face was for the 3.1 to 7 jump. The post is where everything is checked on your machine. The RAM is checked, the CPU is checked, and errors can be indicated by beep codes or on-screen error codes. And they say here, be sure to review this section of the book. The different codes mean different things, and there's a bunch of them. I don't think you need to know them all, but one I'd make sure you know is the errors for the video card and the errors for the RAM. And I'm not going to lie, I'm not going to tell them to y'all because I don't remember which one's which, but one is long beep and one is short beep. And the reason those two are beep codes is if all of the RAM in the computer has failed, the computer cannot display anything on the screen. Your beep code is the only indication that something's happened. And I do believe that is a long beep. And a short beep is your video card, and if your video card's dead, well, obviously you can't display anything on the screen. I'm pretty sure y'all are right on those two. Right. So sometimes it may be necessary to upgrade the BIOS, but the general rule is if you don't need to, don't do it. The reason for that is that it is a touchy procedure when you flash the BIOS on a machine. The only reason really to upgrade the BIOS is if you have updated the hardware and you need it for the new hardware to run. Okay, I told y'all I bought an AMD Black. My motherboard would only run it at 2.9 gigahertz until I flashed the BIOS, because the new BIOS would read the 3.2 gigahertz. So I had to, when I got my machine and got it put together, one of the first things I had to do to get the full speed out of it was to flash the BIOS. If you don't need to do that, though, it's generally something you shouldn't do. The reason is because if something happens in the middle of that flash, you might render your computer unusable. Reasons they say here: faster CPUs, new options, new operating systems, new hardware. In the old days, some of the hardware wouldn't accept extremely large IDE drives. You might have to flash your BIOS to upgrade it to accept drives, I believe it was over 160 gigs. Which is nothing now, yeah, I mean, 160 gigs, though, used to be a really big hard drive. I was reading something on the internet just a few days ago, and they were talking about the first gigabyte hard drive ever built. It was by IBM. It was a box bigger than, you know, 2 of these cubicles, and it cost right at $1 million. You know, and now we think about that. That's, most of us have got more memory than that, you know.
Yeah. Do you remember? When did they build that?
I think it was in the 80s. So it was
Way before.
The digital computer I ever worked on was a simulator was the 60s. 16K block like this. You can see the ferrite core suspended in the read-write sense wires.
See, that would have been crazy to see.
It's unpluggable. You could unplug it and plug another one in.
That is crazy to me. I love to see old stuff like that. One of my favorite things when I go to DEF CON every year is they have a whole set of antique hardware, and they come in and set some of it up and actually run stuff on it. Like they had an old VAX mainframe running at the thing last year doing stuff.
simulator over here across from the museum, and the computer was built in the early 70s.
See, yeah, I want to go see that one day. I know at Louisiana Tech, when I was the admin down there, the state has rules on getting rid of things, and if they were bought at more than a certain amount of money, you can't just put them out in the trash. We had 40 meg hard drives that were in these big blue boxes that were originally attached to an old mainframe, and they're sitting in the corner of the server room because the school paid like, $30,000-$40,000 for these things. So we can't just put them out, even though they're absolutely useless. So, all right, before you do a BIOS upgrade, the procedure they say to use is back up all your data. Record the BIOS settings, or, a new idea. We've all got phones with cameras on them now. Take a picture of the settings. If something does happen and you are able to recover it, one thing you may lose is all your settings. So knowing which hard drive you had booting first and all, it'll just save you trial and error if you do that. Download the BIOS software. Most vendors now, they say, provide an exe that requires minimal effort. That's very true. In the old days, you had to shut down Windows and you'd boot up off a floppy to install a BIOS. Well, most computers don't even have floppies anymore. Some BIOS upgrades still do come as a CD. You have to burn them to a CD and boot it. But now more and more are just updatable in Windows. If you have a UPS laying around, they suggest you plug the machine into the UPS before you update the BIOS. The reason for that, again, is because power interruption can make the whole machine unusable. Most of us probably don't have UPSs at home. So, you just take that risk when you update the BIOS.
UPS?
An uninterruptible power supply, like a battery to run your computer. My advice is just, think about what's going on before you do a BIOS upgrade. If I needed to do one now, okay, fine, I would run it. If it were storming outside, I'd probably wait, because we live in Shreveport and power goes off all the time around here. Just kind of think about things like that. So, when things go wrong, what can you do? Some motherboards now have 2 BIOS chips. My motherboard is an example of one of those. It has one chip that is programmable. The other one is not programmable at all. And what happens is, on my particular motherboard, if it boots up 3 times in a row and it can't post, it sees that it can't read anything from the BIOS or whatever, when I turn it on the 4th time, it will copy the chip from that permanent one over to the other one. So it resets all my settings, they're gone, and it goes back to the defaults and to that original BIOS on my motherboard. Now, in my case, that means the speed's going to slow down, but I've also been able to recover the system because that original BIOS gets copied over. A lot of machines have those now. They also say check for a write protect jumper. Some motherboards have a jumper on them so that you can keep people from writing to the BIOS. Now, why do y'all think that might be something that you'd want to do?
To keep somebody from messing with your machine.
Right, and from a security standpoint now, since these things are programmable from Windows, it is possible to put a virus in the CMOS of a computer. And think about that. You're going to be able to be around any sort of antivirus or anything else if you've got a virus at that level in a machine. Because you've got a virus that's in there before the computer even is turned on, basically, before it boots up at all. I don't think there are many viruses that will do that, but it is a security risk to be considered. So this jumper means that the software can't do it. That way, if you're going to rewrite your BIOS, you got to shut your machine down, pull it out, take that jumper off, and then do it and put the jumper back on. That way you're adding a little bit of security to it. Some they also show have a recovery jumper. In my BIOS, I said it's automatic if it, it'll copy that over automatically if it doesn't boot up right 4 times. Some of them will not do that automatically. There's a jumper you have to move from one position to another, then turn the machine on, then turn it off and move it back before you boot the machine. So that's all based on who you got it from. And ultimately, if you can't do any of those, if the chip is removable from the motherboard, you might actually have to call your motherboard manufacturer and have them send you a new chip. So that is kind of a rundown of CMOS, BIOS firmware, and the post test. Are there any questions on that chapter? What about y'all at home? Any questions? All right, let me so chapter 5 is on power supplies and cooling. And this is something that is very important and very customizable to computers these days. Maybe not so much customizable for a laptop, but if you're going out and buying a desktop, you've got lots of options on these two. And we're going to talk about power supplies and what they do, the various form factors of power supplies and voltage levels. We're going to talk about power protection types, and we'll talk about how to troubleshoot some power problems. We're also going to discuss system cooling. So the power supply in your computer, you'll hear people either call it the PSU or just the power supply. And basically what its purpose is to take power off of the wall, out of the wall, and convert it into what your computer needs. You know, what we have in the wall is AC power, but your computer needs DC to run. In fact, normally it's 3.3 volts, 5 volts, and 12 volts for the different parts of the computer. And the PSU is what does all of that for you. Basically, why is that important? Well, no power means no computing. If you have inconsistent and unpredictable power, you might have trouble with things like hard drives, because those hard drives spin based on what kind of power they're getting. If they're not getting consistent voltage, they're not going to spin at the same speed, so reads and writes might be unstable.
Sometimes the filter caps in the power supply become weak and it'll produce a spike.
Some of that spiking.
That
Now,
really screws stuff up.
I assume a filter cap's, what is that, like one of the capacitors, or?
It's like an accumulator, and you know, you imagine it absorbs all those spikes. When it gets weak, it absorbs them, and when the line tries to go low, it'll provide that energy. And then when it's high, it'll absorb the energy.
Yeah, so it's
So it keeps it level.
You know, when it comes to power supplies, that's one of the things that I don't know a lot about, because in general, there's not a whole lot you can do inside of them unless you do have, you know, a good electronics background like some of y'all are coming from.
The filter's like a shock absorber in your car. It keeps everything kind of
Smooth. In fact, when we get a further in on this on these slides, CompTIA is going to say that if it's something that deals with the power supply, put a new one in. Never open it. Their rule is to never open a power supply, and you should never open a CRT monitor. If you have one of those CRT monitors, you know, most places aren't going to have them anymore, but some of them still exist. So here again, the PSU is not normally repairable, unless you really are into electronics and have done some of that stuff. Generally, when you take a machine into a a shop, if they think it's the PSU, what they're going to say is, let's just replace this PSU.
well, new one would be just like the monitor would be cheaper than
Right.
repairing, unless you do it yourself.
Yeah, repairing a CRT now, yeah, probably would cost you more than just buying. These used to be expensive, these flat screen monitors. Now they're not. They're not expensive at
I
all.
used to work on monitors when I was in Oklahoma for a computer shop, and it was $425 just to take it in the door.
Oh, wow. Yeah, and see, you could buy, I bet you could buy 3 of these for that. I don't think these were much more than $100, these little 17-inch.
You could buy these for $85 now.
Okay, so PSUs are rated in watts, which is volts times amps. It must be set properly. If you've got one of the power supplies that can be used here and in Europe, yeah, they've got this slide wrong. It says 220 versus 220. It's 120 here and it's 220 there. You've got to, there's a little switch on the back of some power supplies that you got to make sure is on the right one for what country you're in.
Oh yeah.
Yeah. So the bigger the PSU rating, the more expensive. Also the more power drain, but the more devices that you can put in the machine. Too little is going to give poor performance. If you buy a small PSU and you put a couple of big hefty video cards in it, your machine's going to overheat a lot and you're going to have all kinds of reboots and problems because it just can't, it can't handle it.
Power supply will regulate as long as the amps don't get too high. If it gets too high, the drain, it'll start dropping the voltage.
So here's that little switch I was telling you all about. Here's their picture of one. I don't know how many have that anymore. I know my new power supply doesn't have one of those. Doesn't have that switch anymore. I think maybe a lot of the mainstream ones like these Dells might, because they probably want to sell the same machine here as they do over there.
Is it because they're not compatible with that? Or is it because now it's internal and it'll automatically switch it?
That's a good question, and I don't know the answer. I should dig into my power supply unit at home and see. I never looked at it. I never looked to see if it had that or not when I bought it, because I don't plan on taking my machine to Europe anytime. Yeah, I don't think they have. They might have. They've come up with all kinds of stuff. I'm not gonna say they haven't made an auto switch,
These
but
machines have one.
A lot of devices come with the plug for in Europe.
Right.
Come with both plugs. You just have to put the right one in.
And maybe that's something. They do come with the different plugs. Maybe it detects from what kind of plug is plugged into it.
Normally, you could get a transformer over there, and then just coming from a military standpoint, they'll give us transformers.
Sockets are different.
Yeah,
Plug the transformer on it. Plug
they got the big heavy duty socket things, the washer and dryer.
Yeah.
Right.
That's what your washer and dryer stove are on.
Is that your?
Not the washer, but the dryer
Dryer.
is 220. And your oven or stove is
Welders.
but it's a 4-prong plug. It's a big old.
So, in determining how much power you need, what they say to do is add up the total wattage of all the devices and divide it by 0.7, which is roughly the efficiency factor. Then round up to the next PSU you could get. So if your system's using 472 watts, by 0.7 that's 674. They don't tend to make them except in hundreds. Now you can get some in 50s, but they're generally hundreds. So get a 700 watt power supply. Note here though, they say that's the minimum you kind of need. So if you were going to add anything to the machine, you should probably look at getting a bigger one. So one thing again that we've talked about, computers don't like heat. And there are lots of things that can happen. A failed fan can cause problems. There are fans all on lots of internal components in your computer now. Your power supply's got a fan. Most graphics cards have got a fan on them, and then your CPU's got a fan. And based on what kind of video card you have, there might be a fan for parts of the North Bridge. Blockage of vents can cause a problem. Dirty intake and outtake on a computer. Those vents get clogged up and that thing will start spinning down a little slower. Generally, there's dust everywhere. We've got carpet and this room is pretty clean, but there's dust in this carpet. It will eventually get in these machines, especially since they're sitting just on the floor in here. And a hot room can do the same thing. If a room gets over about 85 degrees, it can cause some problems. This is also why you want your server rooms as cold as possible. In most bigger businesses, you're going to keep that server room cold, and it's going to have its own separate air conditioning. It's probably also going to have alarms to let you know if that air goes out, so you can get in there and start shutting things down. I know that, you know, over at LSUS, we had our own air conditioning in our server room, and if that sucker went out, as many machines as we had in the server room, it didn't take long. With that air not running, even in the winter, about an hour, and it was 85, 86 degrees in that room. So, you know, we wanted ways to make sure we knew immediately if there was a problem with the air, so we could plan out what we needed to run, or could we shut everything down, or, you know, because if we shut down everything except absolutely critical things, we could keep those running 2 or 3 hours without air. So there are different connectors that connect all of the devices. If for the motherboard, it's a 20 or 24 pin ATX connector. Drives are going to use what they call PATA, but that's also IDE. PATA and IDE are the same thing, based on what, you know, where you hear it from. SATA connectors, then the floppy drive, which uses what's called a mini Molex connector. The fans, which use a Molex connector, I'll show you all those in a minute. I'll show you those in a minute. And then the video card might have its own power as well. Here's an example of some of the different types of connectors that you might find inside of a machine. Take a few minutes and make sure that you are able to recognize these. I know that now they are adding some questions to the test that are graphical. They may show you a picture of one of these and want you to identify it. On my test specifically, the question I got was a Molex connector. And they told me this was going to connect a non-SATA IDE CD-ROM. What type of power would it need? And they showed me the back of the CD-ROM drive with the little Molex on it. And I had to tell them what connector, what power connector would go into that one. The thing that's kind of hard to see on here, but I want y'all to pay attention to, almost all of these now, you see, are keyed. And what we mean by keyed is they're not going to plug in the wrong way. In the old days, you could plug all of these in wrong. You could fry a motherboard. In fact, I remember my first Pentium had the actual power to it was in 2 pieces, and they would plug in backwards. You had to read and make sure you plugged in with those 2 red wires in the middle. Otherwise, you'd fry your motherboard. You can't see it here, but that Molex connector is rounded on one end and flat on the other.
The Molex is the bottom third from the left?
Yeah, the Molex is the one labeled PATA hard disk and optical drives.
Okay.
The mini Molex is the floppy drive one.
Gotcha. Okay.
And you'll notice the floppy drive key is obvious. It's on the top of that one. I'll tell y'all this. Almost absolutely everything in the computer now is keyed. The only thing that I can think of that you can plug in backwards on a machine now at all is the floppy drive cable. And if you plug the floppy drive data cable in backwards, there's a very clear way to know that you've done it. The floppy drive light will come on and stay on solid. So, you know, almost every other cable now in there is keyed. And I don't think they ever worried about keying a floppy, honestly, because who uses floppies anymore? Not very many folks. I don't know what happened to TeamViewer. It's still running, but I don't see questions from anybody at home anymore. So if a question pops up, y'all let me know what they're asking, because I don't want to disconnect it and connect it back. But I closed it somehow and it's still running, so welcome to technology.
Well, it's running on mine. So.
Yeah, it's running, I mean, so. Alright, so you can test the power supply with a multimeter. You can make sure that the different connections are giving out the amount of power that they should be. If you're going to use a multimeter, attach the red lead to the power source and the black to the ground. Here is their picture of just a multimeter meter. It looks like they're testing a battery with it. Here they're checking the motherboard power. And notice there's some variance in it, and some variance is okay. You know, that should be the 12 volt line, and they're getting 11.92. So power does come with some problems, and there are names for those different types of problems. An overvolt is usually a spike. An undervolt is a brownout. Complete failure is a blackout. And then if you hear somebody who, you know, works with electrical stuff, if they talk about noisy power, what they mean is either interference in the line or, you know, it's jumping or things like that. So the way that you deal with those is to put some device on there that will suppress it, like a surge protector, a surge suppressor. A backup is also a way to deal with that. If you get a battery backup that is online, what that means is the power you're getting is always coming from the battery. So the power from the wall is charging the battery. And if the power comes in kind of, you know, spiking and browning out some from the wall, the battery conditions it so that what you get is a clean, what they call a clean power source.
Battery provides a DC to a circuit that creates an internal voltage.
Right, and that's more clean, right, because it's coming out at from a constant supply, I guess.
It doesn't matter what's coming in.
So spikes are momentary, but the voltage can be very high. A power surge, they can last longer than a second. Lower voltage, but potentially more damaging. Surge protectors, they say to look for what they call a TVSS rating and a high joule rating. You also want one that's got a fast response. And a lot of them now, especially if you buy one at home, they even sell these at Walmart, these surge protectors that come with an insurance policy. And if you plug your computer into it and lightning strikes your house and it goes through the surge protector and actually hits your machine, they'll buy you a new computer.
You ever heard anybody actually trying to claim that?
I have not. I don't know if anybody's. I bet it's hard to claim, but
Save your receipt.
yeah, save your receipt. Definitely save your receipt. There's the problem I would have. I don't save receipts.
When receipts fade out, the new type printers, they'll photocopy it, put it in a Ziploc bag, and tape it to your.
That's a good idea, actually. I've gone to trying to scan everything. If it's something I really need to keep, I try to scan it. Because if I can get it on the computer, I can at least back it up. Whether I can find it or not, I know I've got it. But if it's a piece of paper, I may not ever find it.
Computer blows up and where's your receipt?
Right, see, that's why you back all that stuff up everywhere. So uninterruptible power supplies, there are two types. There's UPS and SPS. A UPS, the power's coming from the battery. That's what he was describing earlier, that it makes its own voltage, which is why it's a clean power source. Your power coming in from the wall charges that battery, and that battery powers the computer. SPS is a standby power supply. The power you normally get just comes from the line. So the battery is only used if the if the power fails. They also take a little bit longer to come in. And what they want you to know down here is that most SPSs are marketed as UPS. So that's something you need to read on, you know, if you're going to buy one.
How are they able to get away with that? Yeah.
Just because that's what the industry has done. Because it is providing uninterruptible power, and
Well, technically, it's not uninterruptible.
yeah, you're right. Technically, I don't know.
Wake it up.
They, you know, somebody should take them to court over it, but I don't know if anybody ever will. Your SPSs are usually cheaper because I don't really know why. I don't know if the electronics. Why are SPSs cheaper? Are they easier to make or?
Circuitry. Yeah.
Well, probably if they're not, if it's not ready, if it's not always on, it's got to come on when it senses.
Right.
When going down, it's got to come up, and it's probably cheaper.
Yeah.
Obviously, they do it
Because it doesn't have to run as hard.
As hard.
Some people may want that just as a surge protector. You know?
Right.
They don't care about whether it's like if it's a TV. You don't care if it goes off as long as it doesn't burn out.
As it's protected, that's true.
The computer, you don't want to stay on once the power goes out. You don't want to say, "Well, I got my up, so I can keep working." That's supposed to just give you time to shut down everything.
So, in fact, that's something to look for. Run times. When you're buying one, determine what you need out of it. If they say as a general rule, think about 15 minutes. But that is not set in stone. You may determine that you need to be able to work 2 hours without power. Well, you're going to need a much larger UPS than 15 minutes. But you can buy that. That is available to you. Different ones will have different support. You might get one that has network capabilities. If you're dealing with one that's on a server that's going to have multiple servers on it, you may definitely want a network one, because it can send messages over the network to those servers saying, I've lost the power, I'm at 20%, you need to start safely shutting yourself down. Some have a USB port on them. If you've just got one computer on it, you hook that USB in, and it will at a certain point shut the machine down for you safely.
Those are pretty
The ups for the simulator and Colonel King facility, fill this room with batteries. But, cut it down some.
What's the runtime on it? Do you know?
It's like half an hour.
Yeah, I mean, with y'all got a lot of equipment though.
Get the trainer. Well, the whole thing is to protect the trainer from lightning and stuff.
Right.
If it goes down, and we really lose our play.
And also, the size of the UPS will determine will be based on what other factors you have. Let me give you an example. When I was at the juvenile court, I only needed small UPSs because we had a generator. So I only needed the UPS to run long enough for the generator to kick in. So 15 minutes was plenty of time there. And if I set my servers to shut down automatically, if they didn't get that power, then they'd safely start powering down after about 8 or 9 minutes. And, they'd shut themselves down, but that was normally it only took them usually 3 or 4 seconds for the generator to kick on. However, 4 seconds is enough time for a computer to lose its power, So UPSs are rated in volt amps. And the larger volt amp, the larger the runtime. They say here multiply the power supply wattage by 1.4. Multiply the monitor by 1.4, add them together, that's the minimum size needed. Note, doubling the number can sometimes triple the runtime. The reason for that is because what you're doing there is you're looking at the maximum amount used. If you are, if you're employing any kind of power saving on your computer, you may not be running it at full speed all the time.
Notice 1.4 is twice, that's
0.7. 0.7, right. You're doing the exact opposite of your efficiency factor, I'm guessing.
7 is a big thing in the power world. It's, if you have AC, you can only convert that to DC. It'll be 0.7 of what the peak-to-peak is on the AC signal. Where that peak-to-peak is, the converted DC would be 0.7 of that.
I've always heard that, but why is that? Do you know? Why is 0.7 their magic number?
The signal's going up and down all the time.
So that's just based off the oscillation?
The average of that up and down, if you took each point and then averaged it out, it'd be
At 0.7?
7 of what the total peak is.
Huh. So also they say pay attention to the outlets on the UPS. Many have both outlets that are on battery protection and some that are surge protected only. That's a common thing for home ones. One reason is that, if you've got a laser printer, you don't really need your laser printer to stay on. And that's a huge drain when that laser printer kicks on. So they'll put a port on there that's surge protected but not battery backed up. A lot of the home ones have those now, so that you're getting protection surge-wise, but you're not worrying about, the battery. And don't plug anything into the UPS you don't need to. The less you plug into it, the better it's going to be. So if you've got a UPS, don't plug your lamps and things into it unless you need one for some reason. So sources of problems with power, defects in the AC system, A power supply misconfiguration or failure in the computer. A disconnected CPU fan can be a problem. A power supply or component failure. First step, identify the problem. Remember our troubleshooting process. Identify the problem with the, is it external or is it inside the machine? If a machine won't come on and it's plugged into the wall and you know it's plugged in and the power supply is turned on, start with the most simple and obvious. Try moving it to another plug if you can. It might be something that's nothing to do with the computer at all. It might be a breaker thrown in your house or something like that. Check and make sure the AC switch is set right. Check for a loose keyboard connector. That is mainly with PS2 ports. With USB, that's not as big a deal, but that's also why they said don't ever plug a PS2 keyboard in when the machine is powered up. You know, USB you can plug in and unplug all you want and not hurt anything. Check to see if there's a loose screw that's gotten into something. Has something caused a short circuit in the machine? Verify that the front power supply is plugged in properly. A lot of machines have these power buttons like these do on the front that go into the motherboard that if that's not plugged in right, you can have some trouble with it. It's not the ideal situation, but I have run into places where, you know, that button goes out, and if you can't get another button, what you can do on some motherboards is jump the two together where that plugs in, and then use the switch on the back of your power supply to turn your computer on and off. The problem with that, though, is that that back switch is hardware. Normally this front button, like if you push it on these, it's software. It'll shut the machine down in Windows. That back one's a hardware. When you throw it, you lose power. Your machine's going down. So you got to remember to shut your machine down in Windows first.
Generally, most people actually shut their machine down with start shut down, don't they?
I think so, and I do, even though I know I can push the button on mine. I don't know if that's because I'm old school or not. I always shut it down, and then normally I don't even push the button, you know, except to turn it on, because it'll go off by itself. But I don't know. I mean, you know, some people now I think might just hit the button because it will do it for you. If you're still having trouble, if it's a really old motherboard, it might actually have fuses on the motherboard. Look and see if they've been blown. No modern motherboards probably you're gonna see anything like that on, but it was something that was there. If all else fails, what you might do is try taking all the components out of the machine. Unplug everything, boot up your computer with just your motherboard plugged in. See if it spins up then, you know, maybe it's one of your drives, one of your components, a drive or a card or something. What used to be a big deal, and still is if you're not careful, when you're adding cards to a computer, if you push it down too far, you'll push that motherboard down onto the screws on the bottom that it's held into your case with, and you'll get a short, and you'll have all kinds of problems. It'll just be weird and intermittent. So look for that. Reinstall the cards one at a time until you find it if it is that problem. So faster CPUs mean you need bigger PSUs, which means you're generating more heat. There are two types of heating, active and passive. Active is the use of some powered device to move heat, like a fan. Passive is just a heat sink. Passive never fails, they say. Most motherboards employ both of these. Most have got a heat sink drawing heat away from the CPU, and you're going to put a fan on top of that to pull heat away from the heat sink.
If I remember right, that's what these have.
Yeah, I think all of these do. Almost all motherboards. I don't know that I've ever seen one that just had a fan on it. Not any in modern era computers, at least. They're all mostly going to have that heat sink on it to draw that heat away, and then, you know, a fan to blow it away from that. Because active heat sinks are more effective, they are more useful if the device is generating more heat. The downside, of course, a fan is prone to fail. Anything in a computer that's a moving part, you know, has a risk of failure. Newer passive devices use heat pipes to draw heat away from the onboard north and south bridge sets. If you remember that video where the little battery was, You saw that they actually had heat sinks there. That was for their north and south bridges. So here, passive and active cooling, they're showing a picture of a heat sink and a fan. Case fans, they say normally at least 2. I think that kind of varies. It's really going to be based on what you're going to do with the machine. These have only got 1. They've got 1 big fan in them. And they've got a weird little design thing Dale made that's out of plastic that pushes that air into where they want it to hit on the motherboard. In fact, these do not have CPU fans on them. They have that 1 big fan in the back, and it pushes across the heatsink and pushes the air out. If you're going to build your own machine, you might get a case with a lot more. Like I said, I got 4 in mine because I knew I was going to overclock it here and there. So I got big fans on the side of my case and then a fan in the front and the back. Case fans are typically 80 to 120 millimeters. I have seen cases with 150 fans on them now. So again, you know, things are generating more and more heat the faster we get. Think about some of these new processors they're coming out with, like these Ivy Bridge ones that are going to have 6 cores on them. You're going to need a whole lot of cooling for a 6-core processor. Larger size fans can move air with a slower rotation, which means less noise. That's one of the reasons I like the 120 millimeter fans in the side of mine. When I overclock mine, I don't hear those fans speed up, but I do hear the little fan on my CPU speed up. Almost sounds like a hairdryer when it gets to running full speed. Newer case fans are temperature sensitive. That's a big thing too. Now as they detect more heat, they'll speed up. So here they're showing in the BIOS where it will show the speed of the fan and a warning. The BIOS warning in general, when you set this, it's going to turn the computer off. If based on who made your motherboard now, you may have software to do this, and you'll have multiple settings. I know, like the software that came with mine, there's a setting where you can have it warn you, like pop up a message that says it's getting too hot, and then another setting where if it reaches this point, just turn it off, you know, for safety. So that is a quick rundown on cooling. Are there any questions on Chapter 5? Did anybody at home say there's any questions? Are y'all still with us at home? I didn't lose y'all, did I?
Nope, no question.
Okay, good, good. All right, so this was only a 30-minute file. I'm going to go ahead and do Chapter 6 without stopping the file. Chapter 6 is on RAM, and that's where we will stop today. So this is going to be all about random access memory, or RAM. We're going to talk about what RAM does, a little bit about how it works, and how it relates to your system. We're going to talk about the types of RAM, including in this section, they want you to know some history. They want you to know about some old types of RAM that you're not going to see. I look for a lot of this to go away when the new test comes in, because a lot of this stuff isn't used anymore. Almost all RAM now is DDR. We're going to talk about the characteristics of memory. Do what? Right. We will discuss registered and unregistered memory and what that means. We're going to talk about how to install them, and then how to troubleshoot some of the RAM issues you might have. And finally, what to do to keep your memory up and running and good. So random access, what that means is that memory addresses are located dynamically. It's different from ROM, in which memory addresses are pre-assigned to coded functions. RAM provides the CPU with data to process. Basically, you can kind of think of it like a bucket. Your RAM is the bucket that everything is coming out of and going to the CPU and then going back to. Almost everything in the computer uses RAM in some form or fashion. Keyboard entries are sent to a RAM address. Hard drive programs are sent there. When you pull a web page off the internet, it's going to go to the RAM. RAM is faster than other storage. RAM is faster than a USB drive or than your hard drive. And installing more RAM is often the easiest way to improve performance. With Windows, that is a very, very, very true statement. If you get a slower processor but more RAM, it will almost always outperform a faster processor with less RAM. And nowadays, memory is cheap. Memory is a good, easy way to upgrade a machine. The first machine I had that was a PC had 640 in it, and we upgraded it to 1024, and it was a $500 ordeal. You know, now you can buy 32 gigs of memory for $300 or less. You know, so it's crazy.
The older the chip style, the more expensive it is.
Right. Yeah, now because those are harder to find. All right, so the type of memory will be based off the number of pins and the placement, the number of RAM slots available, the number of RAM banks required for module, and then there's something called dual channel and triple channel support. There are different types of RAM. There's SD-RAM, DDR, and RAM bus. There are actually lots of others, but those are ones that we'll just kind of talk about quickly. And the RAM speed has to match up as a multiple of the front side bus of the computer. Everything has got to be in multiples, if you've noticed that, so that everything can talk to each other. And then error checking is something that some memory has. You generally are not going to buy error checking memory for your computer at home, but you might buy that for a server because, you know, you want to make sure that the server doesn't get any weird errors just because of memory. However, I will say that error checking memory is not just twice. Normally it's 3 or 4 times what the price of just regular cheap old DDR RAM is. So SRAM is static random access memory. In the computer world, that's your L1, your L2, and your L3 cache. And I'll talk more about those caches further on. They don't require memory refresh, and they're used with the CPU to store frequently accessed routines. SRAM is very fast, but it is very expensive, and it's generally not upgradable. Your L1 cache for most machines is actually on the CPU chip. So you're not going to upgrade your L1 unless you upgrade your actual chip. Your L2 generally is close by, but not on the chip. Some it is, some it isn't. Some AMDs actually have L1 and L2 on it, and then L3 is on the motherboard. SD-RAM is synchronous dynamic random access memory. SD-RAM is what was popular as most memory in computers before DDR came around. And we now have DDR, they say DDR2. I have seen DDR5 at this point. Some video cards have DDR5. Basically, that is just all they change on DDR, they're making it faster and faster. This is one of those sections where, like, I hate that the test is going to be behind, but no matter what they do, the test is always going to be behind because memory speeds change constantly. The faster they get memory, the faster that a whole computer, you know, can manage to run. For the test, I don't know that you'll see anything past DDR2, which DDR2 was twice the speed of DDR memory to begin with.
And DDR2 is close to obsolete right now, isn't it?
Yes. Most is DDR3 or above.
Are the numbers exponential?
They have been up to this point. Like, it's each time they've done it, it's twice the speed of the one below it. I don't know of motherboards that have DDR5 on them yet, but I'm certain they're coming. The only place I've seen DDR5 up to this point is actually memory put on a video card. And lots of video cards have memory on their own because, you know, they do so much processing. Like I think I said this to y'all, I know I said it to one class. It's not uncommon to see people spend more on their video card than on their processor these days. So here's some examples of memory. Down at the bottom is a SIM. That was one of the first chips that you didn't have to actually put the memory chips in. I have all of these, and I left it at Bipsy. I forgot y'all, but I am gonna bring it to show y'all these. You know, just so y'all can see them. You guys at home will just have to kind of do with the pictures when we do show and tell day. SIP was one that I never actually had a machine that took SIP memory. SIMs were what I saw after the 30-pin SIM was the 72-pin SIM. Then SD-RAM, and then finally DDR. And if you'll notice in this DDR where the little slot is, that's something they've been doing that I'm glad and I hope they stick to. When they go to a new speed, they move where that key is.
Oh, okay.
So that it won't go in a device that it won't work in. When that's DDR, DDR2's got it slightly off kilter from that. DDR3, I think, has 2 slots. So they do that on purpose so that basically the rule now is, again, in a computer, if it'll plug in, it'll work.
If it fits, it ships.
If it fits, it ships, exactly. So,
See the question? You can't see the question. Somebody has one.
what's the question?
Was SIM the first plug and play?
I don't know. It may have been. That is a good question. I know on my old machine that I was talking about where we added the memory, it wasn't even SIM. I got a piece of foam that had chips on it, and I had to take the chips and put in the motherboard. And then you had to go into the CMOS and tell it you had added memory to it. Yeah, I know. That's also, you know, I got a math coprocessor too. That's when I was really smoking. Yeah, I know. Do any of y'all even know what that is? You know what I'm talking about.
My first computer at work didn't even have a hard drive. 8-inch floppy, it worked perfect on it. Put it in the drive.
Yeah, the 8-inch floppy. I have an 8-inch floppy to show y'all too.
We still use them as old trainers.
8-inch. Yeah, it's bigger than a 5 1/4. It's an 8-inch. It holds 128K if you use both sides.
I remember that.
Use it as a fan.
It's literally
All the threads for the electron workflows.
Wow, I've never even seen it.
Oh wow.
Yeah.
My students, the way I tell the students at Vipsy this, you know, and they're mostly younger students, I'm like, I want you to look at this and look at it closely. This will hold 1/4 of a second of an MP3. Because that's really all you can put on it. It'll hold 1/4 of a second of an MP3.
Well, even the visual system, it was all in electronics because the computers weren't powerful enough. But when you would turn the trainer and the visual was trying to build, you turn fast enough, it wouldn't be able to keep up. And you could actually see it.
You sound like Tom
No, the
Hopkins.
Do what?
You sound like Tom Hopkins.
Oh.
That's what they said on.
Was that one of my Cisco students?
It was Mike.
Yeah, okay. Tell him I'm going to remember that tomorrow.
I just remember
He
it
can
taking
still
like
hear you.
3 or 4 minutes to load something. I do remember that in my computer class in like 8th grade. It's taking like 3 or 4 discs to load something.
We had the big
The little
control data
skinny
disc.
black one. Yeah.
It looked like a cake box. Had 10 14-inch aluminum discs.
Yeah.
And 20 sides, top and bottom, 20 heads, 300 megabytes.
And you picked it up and actually put it in the drive.
Picked it up with a handle.
Yeah.
Put it in, turned it, and pulled the cover off.
I have seen one of those. I've never used one, but I've seen one.
I'll bring some next week.
Bring one, we'll show
Got a
everybody.
150 bag.
Wow.
Yeah, it really is amazing how speed has gone. But a math coprocessor, to answer that question, your old computers pre-Pentium, you could speed them up by adding basically a CPU that did the math, did extra math. It's called a math coprocessor, and like mine was a 386, so you put a 387 coprocessor in it, and it sped your machine up. It was great for things like AutoCAD, and if you're doing Excel or anything.
doing Excel.
Yeah. Well, it wasn't Excel then. It was what was that old one called? Corel bottom, but
Oh man, because we had it on the floppy disk.
yeah, I know, and I can't remember the name of it now. WordPerfect was what everybody used for word
Yeah.
processing, but there was an Excel program.
Yeah, there was.
I'll think of the name of it later.
This was all before I was born.
Probably.
Do
Probably.
you know anybody who still
I'm talking
uses
about
WordPerfect?
I actually do know people that still use WordPerfect.
The courthouse.
The legal industry still
I think they're
uses
the
it.
only people keeping.
I think they are.
It's a lot better than Word. You just got overtaken by the marketing.
Yeah. I moved them to open office at the juvenile court.
Yeah, when I went to work at the courthouse, I was like, "We're perfect." I ain't
Yep.
Well, the reason that so many of them still
Lotus
use it
notes
is because that's
or
what
email.
came out, and that's what all the secretaries learned.
Yeah, exactly.
Right.
And now
true.
that's all that they can use because
docketing
And all those
It is
legal
all compatible.
templates were built into
Yeah.
it.
Right.
You know, because, like, I don't know how much y'all have ever dealt with a court, but you have what's called a pleading.
Yeah.
It's got to have these numbers. It's on legal paper.
Yeah, I know.
All of this crap. And WordPerfect just did all of that. It was all built into it. So, okay, DDR is double the rate of SD-RAM. A PC 2700 minute can deliver 2700 megabits. DDR2 is twice that speed. And then RAM bus was one that came around, RD-RAM, and it didn't last very long. It just wasn't really commonly used.
Busted Rambo drive?
Do what?
That's the busted Rambo drive?
Yeah, the RAM bus.
All that for what? All that for what?
Right.
Just save for later.
So here they're just giving you an example. Know these before the exam. This is one of those tables. They want you to know what types of memory. They might tell you that this is a 168 pin type of memory. What is it? And they'll expect you to be able to figure out from the characteristics they give what memory it is. And you know, it's one of those things I'm going to tell you learn for the test, but in the world, you're not going to run into a machine unless you're working on something ancient that's not DDR. At least DDR, if not DDR2, 3, or beyond.
Well, the other thing
DDR
is it's really easy to figure out
Yeah.
between DDR and DDR2.
Oh, yeah, yeah.
It's
Right.
because of the way the pins are, like DDR1 has one skipped pin, DDR2 has one on either side of it.
Right. Yeah, that's how they started doubling the speeds.
Yeah.
And now you get into this memory where there's actually memory on both sides of the chip. You'll see when I bring some of those, like that SIM,
no, I mean,
memory
like,
was on
the,
one.
The slot, like the way to tell between DDR and DDR2 is the slot, the key.
Uh-huh.
On DDR1, it's missing a tooth on one side, and on DDR2, there's a tooth missing on either side of the key.
Ah, so that it
So
wouldn't
you can look at it
until.
and tell if it's DDR or DDR2 without any stickers on it, without anything.
That's good.
But you can always look it up.
Well, if,
Yeah.
if the sticker's gone, if you don't have anything on there, you can still
Yeah,
tell
you're
if
building
it's
it.
DDR or DDR2.
All this stuff for memorizing.
So, you classify memory in several ways. The amount of memory on the chip, parity or non-parity, ECC and non-ECC, registered or unbuffered, and then single or double-sided. And we'll talk about all of these. Single inline memory module, the first one, single refers to having the same pin out, 30 or 72 pin connectors. Single inline pin package was a variation of SIM. Then DIM module, dual refers to it having pinouts on both sides. So DIMs were your DIMs for laptops, basically. They were smaller so they'd fit in a laptop. Then RAM bus used the direct RAM bus memory chips. So in memory, remember 8 bits is in a byte. Memory is sold measured in bytes. Not really much in megabytes anymore, but typically gigabytes. The memory width refers to whether it has a 32 or a 64-bit path. That usually has to match the path of the processor or motherboard. Generally, what you need to know is anything you buy now is going to be a 64-bit path. 32-bit was the old memory that had a limitation in an operating system and a motherboard. Nothing over 3.2 gigabytes could be recognized by it. If you go buy a brand new machine now and it's got 16 gigs of RAM and you put Windows XP 32-bit on it,
Or Windows 7 32.
or Windows 7 32, or 8 32-bit, any 32-bit operating system, it's only going to see 3.2 gigabytes of the memory.
The Apollo mission had an 8-bit processor.
Yeah, I read somewhere that they did that with 128K of memory too,
8080 they call it.
which is insane. Yeah. Yeah, and 8080, that's even before the 8286s.
I had a little computer that was an 8-bit.
It's crazy to me. I think that's why I like this field so much, is how quick this stuff changes. You know, I'm teaching you all this stuff for the test now, but in 2 years, There'll be a group in here, and it'll be a completely different thing I have to teach them. So the slots must be compatible, of course. You've got to have a slot that the memory will plug into. And multiple banks usually require matched memory in paired modules. For speed, some memory needs to be matched so that you have to use, like if a motherboard has 2 slots, you have to use 2 or 4 slots. You can't just use 1. Most of the more modern motherboards, you can do it with just 1, but it will run faster in what's called a dual channel mode if you can match that memory up. That is why, like if you get on Newegg and you buy, say, 8 meg of memory, it may come in 8 gigs of memory may come in 2 4 gigs chips. You put those in the matched slots, and the machine will run faster than if you put 1 chip in 1 slot. And weirdly, the ones that match are usually not the ones next to each other.
Yeah,
On my motherboard, it's like 0 and 2 that are matched, and then 1 and 3 are matched. I don't know why. There's probably an electronics reason they've done that, but I don't know.
Make sure you don't blow up that one. Like, because usually it's, the 2 different pieces. And it's probably to make sure that one doesn't.
I'm not sure, but I remember a lot of issues relate to address.
Yeah, I bet it. Yeah, something with addressing. So there is parity and non-parity memory. This is where error checking comes in. Parity checking is the use of a parity bit to compute the value that must match another value to validate the data.
The value is the number of ones in the word.
In the word?
If the number of ones is odd, it will not set the parity bit. If the number of words is even, it will set it. And it assumes that it's not going to lose more than 1 bit at a time.
Right.
So if it's all even and you set the bit, and then you lose 1 bit, or add 1 bit, it's going to fail the parity. And there is a decrease in performance, but it's not much, and that's why, because it's just got to add those numbers, like he said. So memory that does that, however, is more expensive. ECC is error correcting code, and that is a type of memory that not only can detect an error, but can correct it. And you typically only see that on servers. And then registered versus unbuffered. Buffered memory or registered memory enable system stability when large memory banks are used. You might put buffered memory in a database server if it's got, say it's a huge, huge database server with 128 gigabytes of physical RAM. You might want to do buffered memory with a big, big set of memory like that, memory banks. So when you're installing memory, memory is one of the components that is most sensitive to electrostatic discharge. You should make sure you ground yourself out before you do put memory in the machine. If you're going to take memory out of a machine, put it back in one of those bags. He's got some electrostatic bags if y'all have not ever seen one. Have y'all all seen what they look like? And that's one reason to keep them. You can put your memory back in them when you're done with it. I think in a pinch, if you had a big bag like I brought, you could clip an alligator clip to it and clip it to the chassis and use that as a
anti-static mat.
Tape.
Yeah, I never thought about that, but you probably could.
It would be better if you didn't have anything.
Right. Hold the memory on the edges. Try to not touch the pins on the bottom. When you go to put it in the computer, check to see if the locking tabs are open. And I'll show y'all that when I bring that motherboard to show y'all. There's little tabs on there, and you want to open them, and when you slide your memory down into it, you push just firmly enough, those tabs will close to hold it in. Line up the notch. Make sure, if you know it's the right memory for that computer, and it doesn't seem to be fitting, make sure you've turned it the right way. Those notches are not in the middle for a reason. They're offset to make sure you plug that memory in the one way that it needs to go. Push straight down to lock it in. And they say here it requires extra firmness, but be careful and don't break it. Here's their graphic showing that. These little white things are the pins we're talking about. Right, when you get it right and get it pushed in, they will. It'll snap down in. So, sources of problems: incompatible memory modules. If you have overclocked your machine, your memory might not be able to handle it. You can overclock it and have memory errors. Incompatible metals in slots or pins. That doesn't happen often, but it can. It can lead to corrosion. And mismatched RAM speeds. So to determine if your cache RAM has a problem, disable the L2 first. If the memory problem goes away, determine where the L2 cache is located and replace it if possible. If it's built onto the processor, you may not be able to replace it. Then disable the L1 cache. If the system runs normally, replace the CPU and retest. If the system runs normally after replacement, the L1 cache was the error. The L1 cache is going to be on the CPU, so if it is that, you're going to have to replace it. When you boot your machine, note the memory count. Make sure that it reached, see where it reached when a memory error, if it was detected. Check the motherboard documentation to see which module should be installed first. Disable cache RAM and BIOS when testing the memory. Change one module at a time, starting with the one you think is defective until the error goes away. They now have programs that you can download that you can run memory tests on. If you really think memory is an error, what I use is a great little tool to just test the memory. Download you an Ubuntu Live CD. You can, the Ubuntu Linux operating system. UBUNTU. And burn you an Ubuntu disk, and when you boot up Ubuntu, one of the options on that menu is a memory test. And that memory test will write to every single address in the memory on a computer and try to read it, so you can test it and figure out from that if it really is a memory problem or not. Sometimes memory problems, or what looks like a memory problem, is not really a memory problem. It's more an operating system issue. It's just my opinion, but with most newer components, it seems that when memory dies, it completely dies. Like, you don't really have much of this, just memory kind of works sometimes and kind of doesn't anymore. A chip's either going to work or it's not. Now, that's not really always the case with some of the older equipment, but with most of the newer stuff, if it's working, it's working. So keep the surfaces clean.
Tyler said, or commenting on it, there is also Inquisitor for 32 and 64-bit system, hardware diagnostics, and a bootable CD.
And it's, what's it called?
There's a Inquisitor. And
Okay.
There's one that's MemTest 86.
I think MemTest 86 is actually what's built into the Linux boot CD. Email me the link to that Inquisitor. I've not seen that. And once he emails me the link, I'll put it up in Blackboard for y'all if y'all want to look at it.
Right. Tyler who said that.
Okay. Keep your memory surfaces clean. Take your can of air before you put memory in a machine, especially if it's been in a dusty environment, and blow the dust out of it. Because those pins are smaller and smaller now, we're packing more and more memory onto a chip. A piece of dust is a bigger and bigger problem if it gets in there and can short it out. If you're really going to overclock your machine heavily, you might put a fan over the memory. Because if you're going to overclock your CPU, your memory's going to get hotter too. So you got to get the heat out of there. Keep the air intakes clean and replace any defective cooling fans. So that is a quick rundown on Chapter 6. Do y'all have any questions up to this point?
He put it on that link in the chat. Inquisitor. Yeah,
okay.
He said it's a Linux bootable disk.
All right.
Do you want? Yeah, might want to say email that to you.
Yeah. I am not able to see y'all's chat window right now for some reason. I don't know. Something happened on this program. But if you would just email me that link so I'll have it, because I kind of would like to check that out. I've not seen it.
He said it's a Linux boot disk, so.
Okay. All right. Any other questions, y'all?
I think that all the RAM chips are actually CMOS
They very well might be. I wouldn't be surprised. I mean, because that is a pretty standard
As long as
type
you
of
turn the power off, it goes away.
right.
And that's the quickest, cheapest, most reliable stuff.
Oh look, okay there. I see the link now. That's weird. It had just hidden and it didn't have a task thing for it. So, all right. Well, no other questions. I'm going to stop our video. I will get this all posted. I want y'all to work with the Cram Master. We've gotten a good portion into this now from 6. So start working through those modules. And again, the first thing I'm going to do Thursday is see if y'all have any questions y'all want me to go over specifically from that.